Hello and welcome to episode 417 of AI Brief. It is Saturday, February 14th, 2026. I'm your host, Amin.
And I'm Leah.
And a happy Valentine's Day to everyone listening. So whether you are spending the day with a significant other or maybe just holding hands with your favorite GPU cluster.
For the warmth.
For the warmth, exactly. We have an incredibly dense show for you today. We are looking at a stack of sources that, well, they suggest we're crossing a few invisible thresholds all at once.
We really are. We're seeing it in theoretical physics, in multimodal reasoning, and finally in the messy physical world of domestic robotics.
It feels like today isn't just about small, incremental updates.
No, not at all. We're looking at AI that's generating genuine scientific knowledge that, humans hadn't derived yet. And we're also seeing robots that are finally learning to deal with soft, unpredictable things like your laundry.
We have a lot of ground to cover. We're going to start with a deep dive into OpenAI's GPT 5.2 and its surprising contribution to particle physics.
And from there, we'll hit Bytedance's massive Seed 2.0 release, which is really shaking up the whole agentic AI landscape.
Then we're going to slow things down a little. We'll look at the hardware world. We've got that laundry folding robot everyone is talking about.
Plus a huge valuation jump for a humanoid maker and a startup that is literally, and I mean literally, weaving robots like rope.
And of course, we'll wrap up with our tactical rundown of the trending AI tools you need to know about. But let's start with the heavy hitter.
Let's do it.
The first story in our stack today is one that I think it fundamentally changes the argument about whether AI can really be a scientist. We're talking about OpenAI's GPT 5.2.
This is a big one. So the headline is that GPT 5.2 has successfully derived a formula for a, quote, gluon amplitude.
Okay.
But if you just read the headline, you really miss the breakthrough. This is not just a calculator crunching numbers faster. This is a system deriving a new mathematical proof from scratch.
All right, before we get into the how, let's just clarify the what. Because I think for most of us, gluon amplitude sounds like something straight out of a Star Trek script.
That's a fair point. So in quantum field theory, researchers study something called scattering amplitudes. Imagine a particle collider, like the Large Hadron Collider.
Right, smashing particles together.
Exactly. A scattering amplitude is basically the complex probability calculation that predicts what happens when those particles collide and, bounce off each other.
So it's the math of the smash.
It's the math of the smash. But the math is notoriously difficult. I mean, as you add more particles and more loops, the equations just explode in complexity. We're talking hundreds of pages of algebra.
So what did GPT 5.2 do differently?
Well, it looked at a specific problem involving gluons. Those are the particles that glue quarks together. And it didn't just solve the equation the long way. It found a shortcut. It found a simplification.
That's the part I found so fascinating in the papers. It didn't just brute force the calculation. It found a more elegant way to express the answer.
That's the key. The model managed to reduce the complexity of the expressions involved. It spotted a pattern that human physicists hadn't fully optimized yet, and it proposed a formula that is valid for all cases in this specific domain.
It basically said, you humans have been writing this in 10 lines, here's how you write it in one.
Pretty much.
Yeah.
But here's where I want to push on the process, because the workflow here is just as important as the physics itself.
Right.
This wasn't a case of a human physicist just using the AI like a fancy typewriter. The AI actually proposed the formula on its own.
It did. So how did they know it was right?
This is where it gets really sci-fi. So the workflow involved another internal OpenAI model that acted as the prover. So GPT 5.2 had the intuition, it came up with the formula.
And then a second AI.
A second, more specialized model formally proved the mathematics to make sure it wasn't just, a hallucination.
So you have one AI as the creative theorist and another as the rigorous mathematician checking the work.
Precisely. And only after that entire loop was closed did the human author step in to verify the process and write up the paper. The result is a new preprint on ArcSuv that's currently being submitted.
It just challenges that old skepticism, doesn't it? The whole LLMs are just stochastic parrots thing.
It really does. You can't just regurgitate a formula that didn't exist in your training data.
Right.
This suggests we're moving into a phase where AI is capable of, ab initio discovery, creating knowledge from first principles. For fields like cosmology or high-energy physics, where the math is just becoming too complex for a single human brain to hold, this is going to be the new standard.
An AI research assistant.
A super-powered co-pilot that can see connections we miss. It doesn't replace the physicist's curiosity, but it augments it in a huge way.
It's a massive leap. But, okay, moving from the theoretical universe to the digital infrastructure that powers it. We have to talk about Bytedance.
Well,
They
yeah.
just dropped the Seed 2.0 series, and the documentation is, well, it's extensive.
Extensive is putting it mildly. This is Bytedance planting a flag in the ground for what they're calling the intelligence frontier for real-world complexity.
Which is just a fancy way of saying multimodal agents, right?
Pretty much. But what struck me is that they're not selling one giant monolithic black box. They've split this into 3 distinct architectures. You've got Pro, Lite, and Mini.
And that segmentation is so important for developers. We're past the one-model-fits-all stage.
Absolutely. So let's look at the top end. Seed 2.0 Pro. This is the heavyweight. It's designed specifically for long-chain reasoning and stability.
Okay, when we say long-chain reasoning, we're talking about tasks that need multiple steps, right? Like, go research this company, then write a summary, then email it to my boss.
Exactly. And the problem with a lot of current models is they get distracted or they just derail halfway through a 10-step process. Seed 2.0 Pro is engineered to maintain that context over a much longer horizon.
So if you're building an autonomous agent that needs to, say, code a whole module or navigate a website to book a flight, this is the engine you'd use.
That's the idea. And then you have the Lite version. Is that just a smaller version of Pro?
It's actually a different balance. Seed 2.0 Lite is trying to hit that sweet spot between generation quality and latency, speed. It's for interactive apps where you need a smart answer, but you can't have the user waiting 10 seconds.
And the Mini.
Mini is all about throughput, deployment density. If you're running a service where you need to hit the API thousands of times a minute, maybe for classification or quick summaries or on-edge devices, you go with a Mini. It's cheap, fast, and good enough.
And what stands out to you about the architecture across the whole series? Because Bytedance obviously has access to a data set that most U.S. companies just don't, specifically all that video data.
You can see that influence, absolutely. In the multimodal understanding, these models aren't just looking at static images. They're incredibly good at what's called temporal perception.
Understanding video and movement.
Right. And that is vital for agentic capabilities. If you want an AI to navigate a computer screen or watch a security feed, it needs to understand the flow of time, not just snapshots.
So the strategy here is all about building the infrastructure for agents that can actually do things, not just chat. It's about stability.
I think the buzzword for 2026 is going to be reliability. We have models that are smart, but can they be smart 100 times in a row without going off the rails?
And Bytedance is trying to say yes.
Speaking of things that need to be reliable 100 times in a row, let's shift gears completely.
I have been waiting for this segment.
We spend so much time on this show talking about code and math, but I want to talk about laundry.
The holy grail of domestic chores.
So Weave Robotics, a startup out of the Bay Area, has opened pre-orders for the Isaac Zero. It is a robot. It sits in your house, and it folds your clothes.
And I don't say that lightly. Folding laundry has been a grand challenge in robotics for decades.
Why is it so hard, though? I mean, we have robots that can do backflips and weld cars. Why can't they fold a T-shirt?
Because a car door is rigid, it's predictable, fabric is deformable, it's floppy, it changes shape the moment you touch it. A robot looks at a crumpled pile of clothes and mathematically it's a nightmare.
It has to figure out where the corners are, how it will drape when you lift it.
And how to flatten it without creating new wrinkles. It's a massive perception and manipulation challenge.
So Isaac Zero, it claims to solve this. But let's look at the reality of the product. It costs about $8,000.
That is a used car.
Or a very, very nice vacation. It is a significant early adopter tax.
And the performance specs, they reflect that too. It takes about 30 to 90 minutes to fold a single load of laundry. It's not exactly speed running your chores.
Honestly, if I'm not the one doing it, I don't care if it takes 2 hours.
Yeah.
But there are caveats, right? It can't handle large blankets. It struggles with bed sheets.
And it can't turn clothes inside out. That inside-out problem is just classic computer vision. Distinguishing the seam pattern on the inside versus the outside is surprisingly subtle for a machine.
But the most interesting part to me about Weave's business model is that they aren't even claiming full autonomy yet. There's a human-in-the-loop component.
The teleoperators. This is the part that makes me wonder if it's, cheating or if it's just genius.
I think it's pragmatic.
I do too.
Yeah.
If the robot grabs a shirt and gets confused, maybe it's a weird cut or a tangled sleeve, it flags it. A human operator, somewhere remotely, sees the camera feed and essentially takes control of the robot's arms to sort out the problem.
So you're paying $8,000 for a robot, but you're also paying for a remote service where a human helps out when the AI fails.
Exactly. It bridges that gap. It makes sure the job gets done so the user isn't frustrated. And at the same time, the robot collects data on all those tricky edge cases to train the model so that eventually it won't need the human.
It's a start. And frankly, for $8,000, those early adopters are basically paying to be data collectors for Weave.
They are. But moving from the laundry room to the industrial floor, we have to talk about Aptronic.
This is a massive financial story. So Aptronic is a spin-out from the University of Texas, and they have just raised an additional $520 million in an extended Series A.
Which brings their valuation to, what is it, $5.3 billion?
5.3. And to put that in perspective, that's roughly triple their valuation from just a year ago. It just shows the incredible appetite the market has for general-purpose humanoid robots.
So is this a bubble? Or is there something tangible here? Because we see all these cool demos, but $5 billion is a lot for a company I don't see in my daily life.
It is a lot, but look at their client list. They aren't just making YouTube videos. They're building humanoids for Google DeepMind. They're working with Mercedes-Benz.
And they have a big partnership with the logistics giant GXO.
So these are being prepped for actual factory floors.
Yes. The thesis here is that we're facing a structural labor shortage in manufacturing and logistics. A specialized robot, like an arm that only welds, is great, but it's inflexible. A humanoid can walk into a factory designed for humans, climb stairs, pick up a box, and press a button.
And Aptronic's valuation reflects the belief that humanoid labor is the next massive utility layer for the economy.
It really feels like we're on the precipice of seeing these things walking around in real facilities. But while Aptronic is building robots that look like us, there's a startup in Budapest called Alonic that is building robots in a way that mimics us biologically.
This story caught my eye because it is so radically different. Usually you build a robot by bolting metal parts together, motors, gears, aluminum frames.
Right. But Alonic just raised $7.2 million pre-seed to industrialize a biomimetic platform.
And the way they build them, they describe it as weaving robots.
It's a fascinating concept. Instead of an assembly line where you screw parts together, they use a process that weaves soft, load-bearing tendons and joints around a 3D printed skeleton. And they do this in a single automated process.
So it's almost like 3D printing a muscle structure.
Closer to knitting a body. I mean, think about human biology. We aren't bolted together. We are a combination of rigid bones and soft tissues like muscles and tendons that hold everything in tension. Alonic is trying to replicate that structure mechanically.
But why? Is it just to be cool, or is there a real manufacturing advantage?
Oh, it's about cost and durability. Traditional robots have thousands of fastener screws, bolts, nuts. Those things vibrate loose. They add weight. They're expensive to assemble. If you can weave a complex robotic limb in one go, you eliminate all that.
You get a lighter, more compliant structure that handles impacts better, just like a human limb does.
And their business model isn't just to build their own robots, is it? They want to be the body shop for the industry.
Exactly. They want to be the infrastructure.
Yeah.
So if you're a startup with great AI brains but no hardware expertise, you can just buy a woven body from Alonic and put your brain in it.
It lowers the barrier to entry for robotics significantly.
It is amazing to see the hardware side really catching up to the software.
Yeah.
You have the brains getting smarter with GPT 5.2 and C 2.0, and now the bodies are getting cheaper and more capable.
It's a convergence. For a long time, AI was tracked in servers. Now, the physical vessels are finally becoming viable enough to let that intelligence act on the world.
All right, let's transition from the future of robotics to the present day of your productivity. We have compiled a list of the trending AI tools that are making waves right now.
Okay, we've got a diverse stack today. First up is Seedance 2.0. This connects back to what we were talking about with Bytedance. It's an advanced AI video creation tool, but the selling point here is precise control.
Right, because usually with video AI, you just type a prompt and you pray.
Exactly. Seedance 2.0 gives you granular control over the narrative. You can direct camera angles, character consistency, pacing. It's moving from generation to actual direction.
Next is one for the developers in the audience, Cline CLI 2.0. This lives right in your terminal.
This is for people who just hate leaving the command line. It lets you run parallel agents and handle headless CI/CD. It basically automates the messy parts of coding deployments, testing, without you having to tab out to a browser.
It's all about staying in that flow state.
Absolutely. For general productivity, there's TexTab. The premise is simple, but really powerful. It turns any AI task into a simple keyboard shortcut.
This is all about friction reduction. Instead of opening a website, copying text, pasting it, writing a prompt, TexTab lets you just bind that whole workflow to a hotkey.
Highlight text, Hit the key, get the result. It treats AI as a utility layer over your whole operating system, not a website you have to visit.
And since it is February 14th, we have to mention Valentine Online.
We do. If you're listening to this and realizing you forgot to get a card, this is your lifeboat. It creates a personalized Valentine's surprise page for your loved one.
It's a nice example of AI being used for something personal and fun, not just enterprise efficiency.
Oh, maybe don't tell your partner an AI wrote the poem.
Yep, valid advice. Back to the technical side, there's OpenBug. I love the tagline for this one. Ticket in, fix out.
It's an automated bug-fixing tool, but the clever part is the learning loop. Every solution it generates helps train the next one, so the more you use it on your specific code base, the better it gets at understanding your particular brand of spaghetti code.
It adapts to your team's style.
Right. And finally, Unblocked AI Code Review.
This one addresses the noise problem in code reviews. We've all used tools that just leave 1,000 nitpicky comments.
Unblocked focuses on high-signal comments, but crucially, they are based on your team's context. It knows how your team writes code, so it doesn't waste time giving you generic advice that doesn't apply to your architecture.
A lot of these tools are really focused on streamlining workflow, aren't they?
It really is about removing friction, whether it's a robot folding your laundry or a CLI tool handling your deployment. The theme today is automation, giving you back your time. We're seeing the tech move from novelty to utility.
And on that note, we're going to wrap up this deep dive.
We hope you found some useful insights in today's mix of theoretical physics and practical robotics.
If you enjoyed the show, please make sure to follow us on your podcast platform of choice. And if you have a colleague who's obsessed with robotics or just hates folding laundry, share this with them.
It really helps the show grow and helps us bring you these updates every day.
See you in the